Every element of the set A will have one and only one image in the set B, and it is denoted as f from A to B is called a function. A function f of x is said to be one function if f of x1 is equal to f of x2 implies x1 is equal to x2. For every y belongs to y, there exists an element x in x such that f of x is equal to y, then the function is called an onto function. Hello dear students, welcome to this session of Mathematics Revision class. I am Mr. Niranjan, Faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. So in my previous class, we have discussed regarding revision in first chapter, that is relations and function. In that we have discussed regarding the definition of relation and also the different types of relations and the problems based on relation. Now in this session I am going to discuss regarding the different types of functions and very important concept, that is the invertible function. Okay, now this is very important session indeed. You are going to get one 3-mark question from this as well as 2 5-mark question from this concept. So this is very important session for your 2022 examination. Right, now let us come to the definition of a function. You are much familiar with the definition of a function and the types of functions like one function, onto function and the bijective function. Let me explain in detail. Now let us come to the definition. What is the definition of a function? A relation f from a set A to set B is said to be a function. A relation f from a set A to set B is said to be a function if every element of the set A has one and only one image in the set B. Every element of the set A will have one and only one image in the set B, and it is denoted as f from A to B is called a function. So if it has only one and one image, so that means it has unique association. So a relation f from a set A to set B is said to be a function if every element of the set A has one and only one image in the set B, and it is denoted as f from A to B. Read it as function from A to B. Now let us consider there are two sets. Let us consider set A and set B. In set A it contains one element and in set B so there is one element. Let us map. This is a mapping A to B. So f from A to B is a function. Here the element A is associated with the element B of the set B. The element A of the set A is associated with the element B of the set B by unique time, then this is a function denoted as f from A to B is a function. So f from A to B is called a function. Therefore, in the function all the elements of the set A is called the domain and the set B is called the codomain. If f from A to B is a function, in this function all the elements of set A is called the domain and the elements of the set B are called as the codomain. Here this is domain and codomain. All the elements of the set A in the function f are the domain, all the elements of the set B in the function B is called the codomain. So here therefore this A is called the pre-image of B under f, whereas this B is called the image of A. B is the image of A under f. That means here B is the image of A under f, whereas A is the pre-image of B under f. So that means this is the image and this is the pre-image. Okay. Now that is regarding the definition of a function. Now by knowing the definition of a function, let us know regarding different types of function. So the different types of function you are going to study is one function, onto function and bijective function. Now let us come to the first one. Before that, let me have one more example for a function. If a function f from A to B and A comma B belongs to f, then f of A is equal to B, denoted as f of A. So we can represent a function AB belongs to f as f of A is equal to B, where B is called the image of A under f and A is called the pre-image of B under f. Now let us consider an example for a function. Here let us consider the set A. A contains 2, 3 and 4. Another set B contains 1, 2. Let us map 2 to 1, 3 to 1 and 4 to 2. Here all the elements of A and B are used and there is a unique association 2 to 1, 3 to 1 and 4 to 2. So that means f from A to B is a function and this 2, 3, 4 domain has unique images. The domain 2, 3 and 4 will have the unique images. Now, let us consider one more function here. A contains 2, 3 and 4. B contains 2, 3 and 4. The mapping 2 to 2 and 2 to 4, again 3 to 3 and 4 to 4. This element 2 is used 2 times. The element 2, 2 and 2, 4. This is not a function because here 2 different images for the element 2. 2 will have 2 different images, 2 and 4. Therefore, this is not a function. Okay. Now, let us come to the next types of function. Now, let us come to the next concept, that is types of function. So, you may expect one question from this types of function. So, they may ask define one function, onto function or bijective function. Let us come to the first one. One function, or it is also called as an injective function. One function or injective function. You might have been studied a function f of x is said to be one function if f of x1 is equal to f of x2 implies x1 is equal to x2. Now, let me define how we are going to define a function f from x to y. A function f from x to y is said to be a one function, or it is also called as an injective function. One or injective function if the images of distinct elements of x and y are distinct. If elements will have distinct images, that is, if the images of distinct elements of x and y are distinct, that is, for every x1, x2 belongs to x, if f of x1 is equal to f of x2 implies x1 is equal to x2. If for every x1, x2 belongs to x, capital X, f of x1 is equal to f of x2 implies x1 is equal to x2, then the function f of x is said to be one function. So, f of x1 is equal to f of x2 implies x1 is equal to x2. If you verify this property, then it is called an one function. That's enough. Okay. Now, let us consider an example. The set A contains 1, 2, 3, 4 and set B contains A, B, C, D. Let us map 1 to B, 2 to A, 3 to C and 4 to D. That means here the images, if the images of distinct elements of x and y are distinct, so this is called a one function. Distinct element will have distinct images. So, 1 to B, 2 to A, 3 to C and 4 to D. So, this is an example for a one function. Now, let us come to the next one, that is an onto function, or it is also called as a surjective function. Onto function, or it is also called as a surjective function. So, a function f from x to y is said to be an onto or surjective function if every element of y is the image of some element x under f. This is an important point. That is, if every element of y, every element of y is the image of some element of x under f. That is, for every y belongs to y, there exists an element x in x such that f of x is equal to y. If f of x is equal to y, then it is called an onto function. That is, for every y belongs to y, there exists an element x in x such that f of x is equal to y, then the function is called an onto function. Now, let us take an example. Here, 1 to A, 2 to A, again 3 to C and 4 to D. So, therefore, this is a onto function. Similarly, see here, 1 to D, 2 to B, 3 to A and 4 to C. Again, this is from A to B is also an onto function. So, that means for every element y belongs to y, there exists for all the elements A, B, C, there exists an element x in A such that f of x is equal to y. This condition is satisfied. So, therefore, this is an example for an onto function. Now, let us come to the next. This is very important function. You may expect this. Define a bijective function. So, a function f from x to y is said to be a bijective function if f is both one and onto function. A function f from x to y, is said to be a bijective function if f is both one and onto function. So, let us consider an example. For example, let A is equal to 1, 2, 3, 4 and B is equal to A, B, C, D. F from A to B is both one and onto function. Let us map like this. So, here f is equal to, now A contains 1, 2, 3, 4, B contains A, B, C, D, map 1 to D. So, 1 to D, again 2 to B, 2 to A, 2 to A, 3 to B and 4 to C. See here? So that is 1 to D, 2 to A, 3 to B and 4 to C. So that means this is both 1 as well as onto function. Therefore, f from A to B is a bijective function. Since f from A to B is 1 as well as onto function, therefore this is a bijective function. Hope you followed. What is a function and the different types of function? 1 function, onto function and a bijective function. Bijective function means a function f from x to y is said to be bijective function if f is both 1 and onto function. This is an example. Let us come to few problems. So these are all 2 or 3 marks questions. Now show that the function f from n to n given by f of x is equal to 2x is 1 but not onto function. Now what is to verify is f of x is 1 but not onto on f from n to n, the set of natural numbers. Now what is given? Given f of x is equal to 2x, f of x is equal to 2x for all x belongs to n, set of natural numbers. Now let us write, let f of x1 is equal to f of x2 implies, what is f of x1? 2x1 is equal to 2x2, which implies x1 is equal to x2. Now let us consider f of x1 is equal to f of x2. What is f of x1? 2x1 and f of x2 is 2x2. So divide by 2, 2 gets cancelled, x1 is equal to x2. That is, therefore, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1 function. F of x is 1 function. Now, since f of x is 1 on n, now by looking to the problem, you can say that f of x is not onto big. Now to verify an onto function. Now whether to verify onto function, whether it is an onto or not. So by clearly we can say by looking to the problem, f of x is not onto because f of x is not onto as 1 belongs to n. As 1 belongs to n, there does not exist any element in x such that f of x is equal to 2x is equal to 1. Here, if 2x is equal to 1 means x is equal to 1 by 2. Therefore, there does not exist any element such that f of x is equal to 2x is equal to 1. So, therefore, f of x is not onto function. It is not an onto function. So, f of x is not onto as 1 belongs to n, there does not exist any element x belongs to n such that f of x, that is 2x is equal to 1. Therefore, this is not an onto function. Now, let us come to the next type. There is one more problem. Same problem. Prove that the function f of x is equal to 2x where f from R to R, where R is a set of real numbers. So, the function f from R to R is given by f of x is equal to 2x is 1 and onto. Here this is both 1 as well as a onto function. Now let us verify whether it is 1 and or not. Now f of x1 is equal to f of x2 for all x1, x2 belongs to R. What is f of x1? 2x1 is equal to 2x2 implies x1 is equal to x2. So therefore, f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1 function. This is f of x is 1 function. Okay. Now, to prove whether it is an onto, to prove that f of x is onto function. Okay. Now, given any real number, let us write, given any real number y in R, capital R. Now, let us write, given any real number y in R, so there exists y by 2, there exists y by 2 in R, given any real number y in R such that there exists y by 2 in R such that, what is f of x? F of x is equal to 2x such that f of, instead of x, let us take y by 2, f of y by 2 is equal to 2 into y by 2, this is equal to y. That means f of x is equal to y. This condition is satisfied. f of x is equal to y. So what do you say? If f of x is equal to y means therefore f is onto function. Therefore f is onto. So finally we can say that therefore f is both 1 1 and onto. 1 1 and onto. See the difference between the first and second. First problem is on the set of natural number f from n to n is given by f of x is equal to 2x is only 1 1 function, whereas on f from r to r f of x is given by f of x is equal to 2x is both 1 1 and onto function. This is an important problem. Now let us come to the next concept, that is composition of function. So composition of function, this is also an important concept. Let f from a to b and g from b to c. If f from a to b and g from b to c be the two function, then the composition of f and g is denoted as g naught f GOF, and it is defined as g naught f from a to c. It is given by g naught f of x is equal to g of f of x for all x belongs to a. So here f naught g of x can also be written as f of g of x, whereas g naught f of x can also be written as g of f of x. This is called the composition of the function. Composition of the function where f from a to b and g from b to c are any two functions. Now here see here a, b and c. Let us consider here what is given. A to b is a function. A to b is a function. Again from g to, yes, g is a function from b to c. So f is a function from a to b and g is a function from b to c. So here this is called the GOF. The function from a to c is denoted as g naught f, that is equal to g of f of x. This is called the composition, is called the composition of the function f and g. So if f is a function from a to b and g is a function from b to c, then this g naught f is a function which is nothing but from a to c, denoted as this g naught f of x is equal to g of x. It's a function from a to c. That is called the composition of the function f and g. Now let us take few problems based on this. You may expect one or two question, one question from this composition of function, either for 2 or 3 marks. Now let us come to the first one. Let R be the set of real numbers if f from R to R is defined by f of x is equal to x square and g from R to R is given by g of x is equal to 2x plus 1, then find f naught g and g naught f. Also find f naught g of 1 and g naught f of minus 1. Let us come to the first one. First find out f naught g. F naught g of x. This can be done as f of g of x. So this is f of, what is g of x? Here f of x is equal to x square, g of x is equal to 2x plus 1. Let us consider this as k, where k is equal to 2x plus 1. So since f of x is equal to x square, since f of x is equal to x square, you can write f of k as k square. So this becomes k square. What is the value of k? Substitute 2x plus 1 whole square. So therefore f naught g of x is equal to 2x plus 1 whole the square. This is the answer. Now to find f naught g of 1, put x is equal to 1, that's all. If you put x is equal to 1, you will get f naught g of 1 is equal to 2 into 1 is 2 plus 1 whole square, that is 3 square. 3 square is equal to 9. That's it. Let us find out the second one. Second one is g naught f. GOF of x is equal to g of f of x. So this is equal to g of, what is f of x? F of x is equal to x square. Let us call it as g of m, where m is equal to, what is the substitution we have taken? M is equal to x square. So since g of x, what is g of x? G of x is equal to 2x plus 1. So g of x is equal to 2x plus 1. If it is replaced by m, g of m is equal to 2m plus 1. This can be done as 2m plus 1. Substitute the value of m. That's equal to 2x square plus 1. Now therefore, what is say? G naught f of x is equal to 2x square plus 1. Now to find out g naught f of minus 1, put x is equal to minus 1. If you put x is equal to minus 1, g naught f of minus 1 is equal to 2 into minus 1 square is 1 plus 1. This is equal to 3. That's it. So this is how we are going to solve the problem. See here, So first one, f naught g of x is f of g of x. So f of g of x is given, g of x is equal to 2x plus 1. Let us represent this as k, then this becomes f of k. What is k? K is nothing but 2x plus 1. So since f of x is equal to x square, if you replace x by k, f of k is equal to k square. F of k is k square. Now substitute the value of k, 2x plus 1 whole square. That means f naught g of x is equal to 2x square plus 1. Now put x is equal to 1. If you put x is equal to 1, then this becomes f naught g of 1 is 2 into 1 is 2 plus 1 whole square. 3 square is equal to 9. F naught 1 is equal to 9. Similarly, on the other hand, find out g of x. G naught f of x is nothing but g of f of x, that is g of, what is f of x? X square. Let us represent this as m. Then this becomes g of m, where m is equal to x square. Since g of x is equal to 2x plus 1, if you replace x by m, you will get g of m is equal to 2m plus 1. So g of m is 2m plus 1. Now substitute the value of x. What is x? M is equal to x square. So this is 2x square plus 1. G or not f of x, g of x is equal to 2x square plus 1. Now put x is equal to minus 1. Then this becomes g naught f of minus 1 is 2 into minus 1 square is plus 1. 2 into 1 is 2 plus 1 is 3. So this is how we are going to solve the problem. Okay. Hope you followed. Now let us come to the next one. Find g naught f and f naught g if f from R to R, g from R to R given by f of x is equal to cos x and g of x is equal to 3x square, and show that f naught g is not equal to g naught f. Now let us come to the next second problem. Find g naught f and f naught g if g from R to R is given by f of x is cos x and g of x is equal to 3x square. Now what is given? F of x is equal to cos x and g of x is equal to 3x square. Let us come to the first one. First one is g naught f. G of x is equal to g of f of x. So this is equal to, what is f of x? Cos x. Now this is nothing but, let us consider this as a k, where k is equal to cos x. Since what is g of x? Since g of x is equal to, we know what is g of x? G of x is equal to 3x square. Suppose if x is replaced by k, then this becomes g of k is equal to 3k square. So this is 3k square. 3 into, substitute the value of k. What is k? Cos x whole square. This can be written as 3 cos square x. So therefore g naught f of x, g of x is equal to 3 cos square x. On the other hand, let us find out f naught g. F naught g of x. So this is equal to f of g of x. F of, what is g of x? G of x is equal to 3x square. Let us represent this as f of, call it as m, where m is equal to 3x square. Since we know what is f of x is equal to cos x, just put x is equal to m, then this becomes f of m is equal to cos of m. So then this is cos of m. Now substitute the value of m. What is m? M is nothing but 3x square. So therefore this is fog x, f naught g of x is equal to cos of 3x square. See the difference? So here 3 cos x square, here this is cos of 3x square. So therefore f naught g of x is not equal to g naught f of x. They are not equal. This is cos of 3x square, whereas this is 3 cos square x. Therefore they are not equal. So you can say that f naught g is not equal to g naught f. If we do this much, we will get 3 marks. Okay. Let me take one more problem based on this. Now, this is also an important problem for 3 marks. So, what is given? F of x is equal to 8x cube and g of x is equal to x to the power of 1 by 3. Find f naught g and g naught f, where f is a function and g is also a function from R to R. So, here what is given? F of x is equal to 8x cube and g of x is equal to x to the power of 1 by 3 are the two functions from R to R. Now first find out f naught g. F naught g of x is equal to f of g of x. So this is f of, what is g of x is x to the power of 1 by 3. Let us represent this as f of k. where as usual k is equal to x to the power of 1 by 3. This is of the form f of x. What is f of x? F of x is 8x cube. Since f of x is equal to 8x cube, so f of k means 8k cube. 8 into, substitute the value of k. What is k? X to the power of 1 by 3. 8 into this 3 and 3 gets cancelled, x. So therefore, fog f naught g of x is equal to 8x. This is 8x. Now let us come to the second part. What is the second part? G naught f of x, g of x. G of f of x is equal, g naught f of x is equal to g of f of x. G of, what is f of x? F of x is 8x cube. Let us represent this as again m, where m is equal to 8x cube. Now since this is of the form g of x, what is g of x? G of x is equal to x to the power of 1 by 3. This can be written as m to the power of 1 by 3. Now substitute the value of m. What is m? 8x to the power of 1 by 3. So this is 8 to the power of 1 by 3, x cube whole to the power of 1 by 3. 3 gets cancelled. This can also be written as 8. 8 is nothing but 8 is equal to 2 cube. So this is 2 cube whole raised to 1 by 3 and 3 gets cancelled x. So this can be written as 2x. So fog of x is equal to 8x and g naught f of x is equal to 2x. That's it. This is how we are going to solve the problem. Okay, hope you followed. Now these are few problems based on a composition of the function. Okay, now let us come to theorems. There are few theorems on this 1, 1 and onto function. Let us discuss the first one. If f from a to b and g from b to c are 1, 1, then g naught f graph of a to c is 1, 1 function. So that is on composition of function. If f from a to b and g from b to c are 1, 1, then g naught f from a to c is also 1, 1 function. This is to be verified. Now what is given here? F from a to b and g from b to c are 1, 1 function. Then g naught f from a to c is also 1, 1 function. What is the condition for 1, 1 function? So we know that if f of x1 is equal to f of x2 implies x1 is equal to x2, then the function is said to be 1, 1 function. This is given. F from a to b and g from b to c both are 1, 1 function. Now given that, now what is to prove? G naught f from a to c is 1, 1 function. Now suppose g naught f of x1, g naught f of x1 is equal to g naught f of x2. This implies g of f of x1 is equal to g of f of x2. So this implies f of x1 is equal to f of x2 because here g is 1, 1 function. G is 1, 1 function. Again this implies f of x1 is equal to f of x2 implies x1 is equal to x2 because f is also 1, 1, because f is also 1, 1 function. 1, 1. So hence what you say? Therefore you can say g naught f is also 1, 1. Therefore g naught f is also 1, 1 function. That's it. So therefore g naught f is also 1, 1 function. That's it. Now what is given? F from a to b and g from b to c are 1, 1 function. What is to prove? G naught f from a to c is also 1, 1 function. Now g naught f, suppose g naught f of x1 is equal to g naught f of x2 implies g of x1 is equal to g of x2. Since g is 1, 1 function, therefore f of x1 is equal to f of x2. Since f is again 1, 1 function, f of x1 is f of x2 implies x1 is equal to x2. x1 is equal to x2. F of x1 is equal to f of x2 implies x1 is equal to x2, means the given function is 1, 1 function. So therefore this g naught f is also a 1, 1 function. Okay. Now let us come to one more theorem like this. So the theorem number 2. Suppose if f from a to b and g from b to c are onto, then g naught f from a to c is also onto. The first one is 1, 1. The second one is an all 2 function. So to verify an all 2, let us consider an element z belongs to C. There exists a pre-image Let us assume there exists a pre-image y of z under G. There exists a pre-image y of z under G. So, such that G of y is equal to z. Since G is onto function, for further y belongs to y, there exists an element x in A such that f of x is equal to y. See here. Yes, since G is an onto function, further for y belongs to B, there exists an element x in A such that f of x is equal to y. Since f is an onto function, therefore G naught f of x is equal to G of f of x. So, G of, what is f of x? F of x is equal to y. Since f of x is equal to y, so G of f of x is y. Since we know what is G of y, G of y is equal to z. G of y is equal to z. So, therefore, G naught f is an onto function. Very simple. See, since f is an onto function, G naught f of x is equal to G of f of x. G of, what is f of x? F of x is equal to y. And again, what is G of y? G of y is equal to z. Therefore, G naught f is also an onto function. That's it. So, if f from A to B and G from B to C are onto means, then G naught f from A to C is an onto function. Now, let us come to the next very important problem on composition for 3 marks. This is also very important. You may expect this for your 2022 examination for 3 marks. Now, let us discuss this. Now, if f from R to R is given by f of x is equal to 3 minus x cube whole to the power of 1 by 3, then find f naught f of x. F naught f of x is to determine, or sometimes they may ask, show that f naught f of x is equal to x. Now, let us verify first one. What is given? F of x is equal to 3 minus x cube whole raised to 1 by 3. Okay. Now, so now f naught f of x, f naught f of x can be written as f of x. So, this is equal to f of, what is f of x? 3 minus x cube whole raised to 1 by 3. Let us consider this as f of k, where k is equal to 3 minus x cube whole raised to 1 by 3. Now, since we know what is f of x, since f of x is given function, that is 3 minus x cube whole raised to 1 by 3. Substitute here. If x is replaced by k, what you will get? 3 minus k cube whole to the power of 1 by 3. Now, just substitute the value of k. What is k? K is nothing but this is the value of k. So, this can be written as 3 minus k. What is k? K is equal to 3 minus x cube whole raised to 1 by 3 whole to the power of 3 whole to the power of 1 by 3. See here, 3 minus k. K is 3 minus x cube whole raised to 1 by 3 and this whole cube whole to the power of 1 by 3. Now, this 3 and 3 gets cancelled. What you are going to get? This is equal to 3 minus, multiply by negative sign, minus into minus plus x cube whole to the power of 1 by 3. So, minus 3 plus 3 gets cancelled, x cube whole raised to 1 by 3, again 3 gets cancelled, this is equal to x. Now, what do you say? Therefore, f naught f of x is always equal to x in this case. So, therefore, f naught f of x is equal to x. That's it. Okay. Very important and very simple problem. Definitely, you may expect this type of question for your examination. So, this type of problems you have to practice. Since we are doing the revision classes, so I will take only few problems, selected problems on each type. Now, let us come to the next one is the very important concept, that is the invertible functions. So, invertible function. What is the definition? A function f from x to y is defined to be invertible if there exists a function, there is a function g from y to x such that g of x, g naught f is equal to I of x and f naught g is also equal to a I y, then the function g is called the inverse of f and it is denoted as f inverse. That is, a function f from x to y is defined to be invertible function if there exists a function, that is g from y to x, that is g naught f of x is ix and f naught g of f naught g gop is ix and fog is equal to iy, then the function g is called an inverse of f and it is denoted as f inverse. That means a function f is invertible, then f must be both 1 1 and onto, and also conversely. So if a function is invertible means then the function is 1 1 as well as an onto function. So here I of x and I of g naught f of x is ix and g naught f fog and gop. So then the function is called an inverse of f and it is denoted as f inverse. Now let us take a problem on this. So this is very important for 5 marks. Usually you may expect this type of question for 5 marks. Very important problem. Consider f from R to R given by f of x is equal to 4x plus 3. Show that f is invertible. Find the inverse of f. This is definite question for your 22 examination. What is to prove here is f is both 1 1 and onto, and we have to find the inverse for this. So a function is invertible if and only if it is 1 1 and onto, that is bijective function. Now first verify f of x is 1 1, then onto, then find out the inverse. That's it, very simple. So you will get 2 marks plus 1 mark for the finding the inverse of the function. What is given? F from R to R, a function f from R to R is given by f of x is equal to 4x plus 3. Show that f of x is invertible and hence find the inverse. Now first find out whether it is invertible or not. To verify if it is invertible or not, verify whether it is 1 1 and onto. Now let us consider what is given. F of x is equal to 4x plus 3. For all x1 comma x2 belongs to R, for all x1 and x2 belongs to R, f of x1, f of x is equal to 4x1 plus 3 and f of x2 is equal to 4x2 plus 3. Just replace x by x1 and x2. Now f of x1 is equal to f of x2 implies 4x1 plus 3 is equal to 4x2 plus 3. So 3 gets cancelled. 4x1 is equal to 4x2 divided by 4, x1 is equal to x2. What do you say? F of x1 is equal to f of x2 implies x1 is equal to x2. So f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore you can say that f of x is 1 1. The first part is finished. So if you do this much, you will get 2 marks. The first part, 2 marks. Now to verify f of x is an onto function. Now the second part, to prove that f of x is onto function. Let us verify onto function. To verify f of x is onto function. Now what is given? F of x is equal to 4x plus 3. This is given. Let y belongs to capital Y. Let y belongs to Y. There exists x belongs to n such that f of x is equal to y. What is f of x? F of x is nothing but 4x plus 3. 4x plus 3 is equal to y. Get the value of x. 4x is equal to y minus 3. X is equal to y minus 3 divided by 4. Y minus 3 by 4 such that f of x is equal to f of y minus 3 by 4 can be written as, what is f of x? 4 into x is y minus 3 by 4 plus 3. This gets cancelled. This is equal to y minus 3 plus 3 is equal to y. So such that f of x is equal to y. Therefore f of x is onto function. That's it. So f of x is equal to onto. Now since what we say, therefore f of x is both 1 1 and onto, since f of x is both 1 1 and onto, therefore f is invertible function. This is bijective and therefore invertible. F inverse exists. F inverse exists. Now to find f inverse, let us write like this. Let f inverse of x is equal to y. This implies f of y is equal to x. That is nothing but 4y plus 3 is equal to x, or 4y is equal to x minus 3, y is equal to x minus 3 divided by 4. So what is y? Y is nothing but f of x. So therefore, f inverse of x is equal to x minus 3 divided by 4 is the inverse for the given function. That's it. So f inverse x is equal to x minus 3 divided by 4. That's it. Since the given function is both 1, 1 and onto bijective, therefore the inverse f inverse of x is equal to x minus 3 divided by 4. That's it. So this is how we are going to solve. So the same problem can also be solved using g naught f of x and f naught g of y. Okay. Any method you can follow to solve this problem. That's all regarding today's session. Let us meet with different types of problems in the next session. Thank you. Thank you very much.